So, following on again, we're just going to learn a new rule, okay? Yes, in the last lesson we looked at the product rule, and now we're going to add a further rule, and this is going to be the quotient rule. Okay, so we have all these new tools that we can use to differentiate all sorts of functions. So let's have a look at the function here. We have y equal to some function divided by another function, okay? And it might be simple to just rearrange this function, right? So we could rearrange this exact function into x cubed plus 1 and then bring this using our index laws up to the top. And now we just have a product, and so we could just use the product rule to differentiate this. However, what if we would rather like to consider it as a quotient? Okay, so is there a quotient rule? Okay. Well, the quotient rule is derived from the product rule. And if you use the product rule and the quotient rule on the same two functions, you might find that when you use the product rule and you have to simplify, you'll find it would have been easier just to use the quotient rule because it's been built around simplifying the expression from the beginning. So let's think about what we have here. Let's say we have some function y equal to u over v. So u is some function and v is some function, right? So they are a quotient of each other, and we want to find what is the derivative. So in other words, we're saying, let's consider what is the derivative of u of x over v of x, where u and v are just two functions of x. Like, for instance, this could be u and this could be v. They're both functions of x. Okay, so I'm going to rewrite this in index notation, and I'm just going to simplify all the x's just so we don't get, it's not too messy. So basically, we want to find the derivative of u, and then when we bring v of x to the top, you saw that it became to the minus 1. So this is v to the minus 1. Okay, so we are quite literally going to use the product rule on this. So I'm going to call this function u and this function v. I know it's confusing, but just keep track of it. When we differentiate using the product rule, we use v u dash plus u v dash. Okay, that's the derivative, the rule for products. So let's use that and differentiate this function. So we're going to take v. So v in our example is just v to the minus 1. And we're going to multiply it by the derivative of u. So the derivative of u would be u dash, or it would be du on dx. Okay, so if you had to differentiate this function u equal to something, its derivative would be du on dx. Okay, it's just so we can see the terms separately. Okay, and then we're going to add that to u. U is just u, and then we're going to multiply that by the derivative of v. Now we have to be careful, because remember what v is. V isn't just a function, it's a function within a function. So as soon as we brought it up to the top, it now became a function of a function, and we need to use the chain rule to differentiate that. So when we differentiate using the chain rule, we multiply by the power. So the power here is minus 1. And then I'm going to reduce the power by 1. So if I reduce the power by 1, I'm going to get v to the power of minus 2. And then I need to multiply by the derivative of the inside function. So the derivative of v, if we just looked at v, would be dv on dx. Okay, so we can just tidy this up a little bit. So we're going to get v to the minus 1 du on dx minus u v to the minus 2 dv on dx. Okay, so these v to the minus 1s, what we can do is we can send them back to the denominator. So we're going to get du on dx all over v. And we're going to take away u dv on dx all over v squared. So I'm just going to add these terms together, so I need a common denominator. So here I have v, here I have v squared. So if I multiply the first term by v at the top and the bottom, I'll have a common denominator. So I'm going to get v du on dx all over v squared and minus u dv on dx all over v squared, which I can combine into one term. So I'm going to get v, and du on dx happens to be the derivative of u. So u dash. And u times the derivative of v, which is just v dash. And this is all over v squared. And so this is what we call the quotient rule. So v u dash minus u v dash all over v squared, or vuv on v squared. The only difference here is instead of having plus, we have a minus. So the reason why I like this format is because it's similar to the product rule. So this is for d by dx of u over v, and this is for d by dx of u times v is v u dash plus u v dash. In the product rule, the order that you differentiate it wouldn't have mattered. However, here it would make a very big difference, the order that you differentiate the term. And so if we learn to differentiate them in the correct order, bearing in mind the only difference is there is a minus sign here, and also we have v squared on the denominator, the order that we would differentiate at the top is the same. So we take the derivative or the second function multiplied by the derivative of the first function, and then the first function multiplied by the derivative of the second function. So it keeps the order the same.